Okay. Hello, everyone. It's a pleasure for me to be with you today with my presentation of the scientific article called Structural and Architectural Design of the PHAXSI Lunar Analog Habitat over environments similar to the Moon, whose authors are Loreto Sanjines and Alejandro Herrera. The content of the presentation is introduction, objectives, method, results, conclusions, and reference, and context. We are going to comment on we will take in the first part of introduction. First, we begin by talking about the missions to the moon. As many of us know, Artemis is a program focuses on bringing humanity back of the natural satellites. This last century, there were many missions from various space agencies, as we can see some of them. About human settlements on the moon, there is much to say, but I will try to rescue the most important in this presentation. Space habitats can be divided into three categories: short, medium, and long. The volume of the depend of the volume of the size of the crew. And it's important to mention that each habitat is different, but we have some common objectives, such as that we all seek to contribute to science. The table shown below is the design of steps for a spatial room. It's important to take it into account. In this slide, we can highlight the characteristics and requirements that there will be to achieve human settlements on the moon. For example, as a table physiological and psychological support for humans, forgiving failure modes, and other. In the next slide, we can see more requirements about the human settlements on the moon. And about the procedures, we first need to analyze the needs of the user, design, environment, mission objectives, and we can contribute with a comfortable, technological, sustainable, and innovative design for our future analog astronauts. In the following table, we can observe the requirements that are needed for the design of the space habitat, taking into account considerations such as lunar dust, radiation, and among others. The importance of analog missions, which belong to the very near future in which humanity can reach other celestial objects, we prepare for the future. Where we create analog astronaut missions, analog astronaut teams, where we carry out experiments to contribute to the space area. Then we see three objectives of the analog missions. For example, we can see not all experiments can be done in space. There is not enough time, money, equipment, and manpower. They can be tested on analog before testing them in space. Those that don't work and analog will not fly in space. And ground-based analog studies are completed more quickly and less expensively. In the next slide, we can see about the objectives. In the objectives of the PHAXSI, the Habitat Lunar PHAXSI, first development of a safe, self-sustainable, smart habitat and lab concept with high-tech, green and social development content. Or optimize use of resource and autonomy regarding water, energy, and communication, contribute to research in natural environments with special characteristics such as high radiation and increase of safety, efficiency, and performance for operation in extreme environment conditions. Incentive program for scientific divulgation and space technology in Bolivia and South America, create opportunities and projects in the space file in Latin America, and incentive the new generation of Latin America astronauts and cosmonauts. In this slide, we can see the index of these three parts that are the methods and are a study of the land, selection of the type of construction and habitat materials and habitat characteristics. First, a study of the land and location and final location of the habitat in Bolivia. For example, territory in Bolivia, we had a multiple and exhaustive choice in order to choose the most appropriate environment based on scientific arguments that would be similar to an interplanetary environment on Earth. So in this slide, we will talk about the selected region and its the Salardo unit. Then we will argue based on arguments drawn from scientific research already carried out. The region has one of the highest level of solar radiation on the planet. It's important to mention. Usually the levels of UV radiation leave the international scale and other characteristics about the atmospheric pressure with temperature, um, the close in this region is craggy volcan desert with the presence of geothermal, others, geysers, and possible lava tubes. So the Salardo unit it has several characteristics that make it suitable for these simulations, such as the fact that it has millions of tons of salt and it's the largest lithium reserve in the world. And the Salardo unit and the astrobiology, such as the study, for example, dissolution and formation of salt crystals or extremophile organisms and cyanobacteria tolerant to high concentration of salt, and many studies in this place. So the winds are intense almost all the year because they can reach speeds of more than 90 kilometers hours. And is this place a propitious place to be an astronomical observatory due to its characteristics clear sky during the majority of the year. About the structure and selection of construction type. We talk about the structure. We must select the type of construction that will be done. We divided it into approximately 7. Type A, type B, type C, type A, type F, and type K. And about the type A, steel structure, there are the types of construction that are characteristics by having a structure or support made of steel. Type B, concrete structure, in this group are all the buildings that have a reinforced concrete structure as a support. Type C, a brick structure. Type A, wooden structure. Type F, adobe structure. And type G, precast metal structure. Like construction with metal supporting structure, generally one story. Galvanized steel up, and type K, like concrete construction. But we uh, we can see the type I because one of the quite appropriate materials is steel for now, since it's a habitat on Earth. When it comes to space habitats, you have a more exhaustive choice of materials, and the results of steel are the tile below, which is the most convenient material unlike the previous one. This material is important because when making a list of requirements, we determine that the following details are important. Steel can be lighter than other materials, being a movable structure. Steel is a resistant material in these cases. And the surface of the land is irregular and being movable, the structure will not be leveled in the new conditions. So uh, we we can see in this slide the characteristic of habitat. The habitat is regarding the structure and internal details of the lunar habitat is divided into the following sections: greenhouse, toilets, garage or observatory, health center, laboratory, ground station and communication, kitchen, bedrooms. Okay. Innovate feature are the pillars, which are designed with are designed this way with objective of prevent. Sorry, I um. Can you see, Professor? Sorry, this is like I have a
Yes,
problem.
yes.
Okay, okay. Yeah, the pillars are innovate characteristics part of the habitat since their function is to prevent the entrance of lunar dust and internally it's to be a water storage. They are also important since in this region there are times of the year where there is rain and therefore small floods of water. The next slide is about the greenhouse. Greenhouse, which is located in the middle of the entire habitat. This in order to study through space agriculture and to be able to contribute when the region reaches to high radiation level and contribute to future advances crops on the moon. And laboratory is important to mention because this is one of the most important sections within in the habitat since multiple science will be used such as chemistry, biology, astrobiology, physics, studies, among others. And about the sustainable, today we will live in a world where our resources are limited. PHAXSI is aware of this, which is why he will seek the path of sustainable below is the major global innovation in habitats along with optimization and security. And for example, in the world, the great resource available, self-sufficiency, sustainable have become important issues today. About results, as a result, we get the following applicable systems: assemblage of a rainwater collector, aquaponic system, biogas digester, photovoltaics, a solar cooker, a solar head panel, algae photobioreactor, the biodiesel processor. And when all these systems are combined in a nothing is wasted concept, they could produce a semi-closed loop system with the only inputs being solar energy, rainwater, and human energy and outputs to feed one person's requirements. As a result, we obtain a structure based on materials that can resist the conditions of the region and the solar unit, making all kinds of material for each part, thinking about its quality of structure and infrastructure. So about the conclusions, the structure and architecture of the PHAXSI analog habitat is focused on being an optimal, innovative, and sustainable design with innocuous materials for health and ecological, so as not to the environmental. environment, as well as with systems conducive to the reuse of possible resources and energies. Therefore, the habitat will be in the region with many special characteristics to simulate an intergalactic habitat, which will first to be the moon. This contribution means the coming of a series of new research in new um, space science, from the design and testing of space suites in analog simulation, design of file work, protocols, and other activities. And the reference webs, the some information, and as additional information, PHAXSI is currently an active member of the cluster of the space industry of Mexico. It will be present at FAMEX, and a few months ago, we also gave a presentation on this project for Moon Village. Below we leave our contact. You can look for us at Instagram, Habitat Lunar PHAXSI, and contact with in email for other questions. And thank you very much, Habitat Marte, and estimated Professor Julio Resende.